we'll showcase how to analyze and visualize high CPU utilization across components within a large call graph. We're going to do that using PuppyGraph's powerful query capabilities. By querying historical records related to components with a high CPU load ratio, that above 0.9, users can swiftly identify patterns of heavy usage and the associated component and invocation information. Additionally, the application of the PageRank algorithm ranks the importance of each component, providing insights into which components are critical within the network and might need optimization or monitoring to prevent system overloads. This practical approach helps in proactive system maintenance and optimization in complex environments. Currently, PuppyGraph can be launched in two main ways. The first way is through Docker, which is going to allow you to run PuppyGraph anywhere that you can run Docker. Secondly, you can also launch PuppyGraph through the AWS Marketplace, and soon you'll be able to launch PuppyGraph through the GCP Marketplace as well. Today, I'm going to show you how to run it in Docker. So for Docker, you can simply come to our PuppyGraph docs, click Getting Started, launching PuppyGraph in Docker, and then following our step-by-step tutorial here is just a couple steps. First, you'll need to make sure that you have Docker installed. Then, after Docker is installed, you'll then start a PuppyGraph container using this command. Just one note is that this command means that when your container is stopped, based on this --rm flag, this is going to completely remove the PuppyGraph instance. If you want to keep the instance so that you can start and stop it, just remove this -rm flag. Of course, if you want to make further tweaks to this run command, you can do that as well as needed. Once you run this command, the PuppyGraph image will be pulled down, and then the system will boot up. Once you've got PuppyGraph up and running, you can then proceed by logging into it. The default credentials will be PuppyGraph as the username and PuppyGraph123 as the password. Our next step, once we've logged in, is to upload our graph schema JSON. Now, there's other ways to do this as well. We can also use the create graph schema functionality, which is going to allow us to connect to a data source and then use the UI to design the graph schema. Or if you don't have a schema, you can also use one of our example schemas as well. That being said, today what we're going to do is use a JSON file that contains our catalog connectivity details, as well as how to map the data from our SQL data source over into PuppyGraph. Now, what exactly does that schema look like? Here is an example of our big call graph JSON. And this here is going to contain all of the data that we need to link our SQL data source over to PuppyGraph. At the top here, you'll see that we've got catalogs, which includes a catalog name, type, and metastore information, such as the warehouse and some credentials so we can connect to that data source. Now, if there's multiple data sources, we can also add them into this array as well and stitch together that data across multiple SQL data sources. Just underneath that, we have vertices or nodes. And here you can see that each has a label. It has a map table source, which is going to allow us to map the SQL data into this node. Underneath that, you'll see attributes, which allow us to say which attributes that node is going to have and where to pull it from the SQL data source. Then as we scroll down, we'll see more of these nodes, and eventually we'll come to edges. And under edges, we'll be able to see that each has, similar to the node above, it has a label and a map table source, including a to and from, so that we know which data is part of this edge mapping. Then under there, you'll also see that we have a from and to node field. So these depict which nodes this edge will run from and to. And then below that, we also have attributes. If we scroll down, we can see that we have many more edges within this particular schema, but it is complete enough for us to upload it into PuppyGraph so we can start querying that SQL data. Coming back into here, we can then come over to choose file, choose the file that we want to upload, and then after that, we'll click upload. With the schema loaded, we can see that the schema is now represented visually in PuppyGraph. Since our schema is now available, we can begin to use the underlying SQL data as a graph. We can do this either through the dashboard, which allows us to create and save the graph queries and display them in various formats. We could also use the Visualize tool to explore the data with a more traditional graph visualization approach. Or we could come to the query screen and run queries that can be output as a graph visualization or as a table result. For instance, let's run a query that returns historical records and related components with a CPU load greater than 0.9. In the returned result, we can see a visual representation in the pane to the right. We can interact and further explore this data in the pane as well without writing a query. If we want to expand the result, we can use the Expand with All Edge Labels feature to then further enhance the data within the visualization. Next, let's run another query that will query historical records of components with CPU usage exceeding 90%, as well as corresponding component and invocation information. In the result, we can see the components, component history, and various edges that connect the nodes. We can also look at specific fields that the node has, such as the actual amount of CPU usage. Lastly, let's flip over to the Cipher console and run a query to rank the importance of each component using the PageRank algorithm. In the return result, we can see the component ID as well as its score based on the algorithm. And with that, we've looked at how you explore a SQL-based system load analysis dataset as a graph using PuppyGraph. For more information and to try out PuppyGraph for yourself, head over to www.puppygraph.com.